everyone, welcome to Platform Stability Sections. My name is Dong Ma. I am a senior software engineer here at Roku. Today, I'm happy to talk about the memory performance for this year's Developer Summit. Let's walk through today's agenda. First, we will talk about memory in RokuOS. We will look at how Roku device manages memory at the system level, the constraints we need to be aware of, and how these limitations impact kernel performance and stability. Understanding this will help you design more efficient apps. Next, we will explore system-level memory APIs. These are provided by RokuOS that let you inspect and monitor memory usage across the entire system. We will discuss when and how to use them, and how they can help you detect potential memory issues before they become critical. After that, we will move into channel-level memory APIs. These APIs give you insight into memory usage within your own channel. We will see how to track memory allocation and optimize your code to keep your channel running smoothly without existing device limits. Finally, we will cover temporary memory management. We will discuss strategy for holding short-lived memory needs, such as caching, buffering, and working with large data sets in a way that feeds resource quickly and avoid unnecessary strain on the system. I would like to remind everyone that we have a forum to pose questions during the panel by following the QR code or visiting the link listed here, and we will answer these questions at the end. Let's start by talking about memory in RokuOS. Memory is one of the most critical resources on Roku device. Unlike a desktop or high-end mobile device, Roku device has limited memory resource. So how we manage it directly affects both system stability and channel performance. If a channel uses too much memory or has memory leak, the channel could slow down, become sluggish, crash, or even cause the system to close it. This is why memory management is so important. In fact, Roku tracks this in the channel stability report in the developer portal. This report shows how your app is performing with metrics based on blind script crashes and memory closures. If memory closures are high, it is clear sign that your app is exceeding resource limits and need optimizations. To prevent these issues, we have system-level memory API. This lets you see the bigger picture, how much memory is available across the device. Channel-level memory API, these focus specifically on your own app's memory usage, helping you pinpoint where the apps might be holding on resource longer than necessary. For development and testing, you can also use Roku Resource Monitor, RRM. This is a powerful tool that lets you track memory usage in real time while running your channel. It is extremely useful for spotting spikes, leaks, and inefficient memory patterns before you release the apps to productions. In short, by understanding RokuOS memory constraint, using the right APIs, and monitoring with RRM, you can keep your channel more stable, fast, and reliable, which ultimately means better experience for the users who are using your app. Now, let's talk about the system-level memory APIs in RokuOS. These APIs give you insight into overall memory status of the device, which is critical for making smart decisions about resource usage. They are part of if device info interface and are supported on all current and updatable Roku device models. There are two methods. Enable low journal memory events. This API allows you to enable or disable low journal memory level event notifications, passing in parameter set to true to turn on notification or false to turn them off. It returns a flag indicating whether these notifications are currently enabled or disabled. By enabling these, your app can be alert when the device memory level drops too low so you can respond. For example, by filling up resource or reducing memory usage before bad things occurred. Get general memory levels. It checks the current general memory level of device. It returns a string that can be one of normal, which memory is healthy and there is no immediate concern. Low, memory is starting to run short. You should consider filling resource. Critical memory is extremely low. Action is needed immediately to avoid crash or force closure. This gives you real-time feedback on the device memory status, so you can adapt your app's behavior dynamically. In practice, you might use these two methods together. Core enable low general memory event to get notified when memory drop. Use get general memory level to check the current state and decide what to unload or optimize. By leveraging this system-level memory API, you can make your channel more reliable and less likely to crash under low memory conditions, which ultimately improves stability across all Roku devices. Now we have covered system-level memory API. Let's move into channel-level memory API. Why system-level API tells you about overall device memory. Channel-level memory API focus specifically on your app's own memory usage. These are part of if app memory monitor interface, and they are extremely valuable for keeping your channel stable and responsive. Enable memory warning event. It will let your app receive a warning when it hit 80% of its memory usage limit. The parameter true to turn on memory alert, false to turn them off. It returns a Boolean indicating whether alerts are enabled. This gives you an early warning before your app runs out of memory, so you can free up resource before the system forces a closure. Get memory limit percent. It returns a current percentage of channel memory limit that is in use. It returns an integer between 0 and 100. This is great for real-time monitoring. For example, you could log and display memory usage while testing to see how close you are to the limit. Get channel available memory. It returns the estimated kilobytes of memory still available for your app. This helps you to decide how much to unload when memory is tight. Get channel memory limit. It returns an object with 3 key values. Max foreground memory, the maximum memory available when the app running in the foreground. Max background memory, the maximum memory available when app is in the background. Max Roku managed heap memory, the maximum heap memory RokuOS may allocate for your app. For example, video and audio buffer, which RokuOS allocates for video playback. This is incredibly helpful for debugging memory-related crashes and understanding different scenarios, like when the app is playing video or suspended in the background. These API work on current and updatable Roku device, except for a few models: Liberty, Austin, Mustang, Littlefield, Footland, and Chico's. For current RokuOS version, you need to add a line run underscore as underscore process equal to 1 to your manifest file in order to use all these APIs. In summary, channel level memory API give you direct insight into your app's memory footprint and provide alerts when your app is getting close to critical limit. By combining these APIs with good memory management practice, you can keep your apps running smoothly, even on the device with tighter memory constraint. Let's talk about temporary memory management in RokuOS. Files in temp:. These files are managed entirely by the app. You create them and you delete them. They are not retained once the app exits. Everything in temp: is clear when your channel closes. Because you control cleanup, if you leave large file in temp: while the app is running, they will continue to use your app's memory and could lead to performance issues or even crashes. If you use memory API, when you receive the low memory notifications, it is the time to remove some of the file in temp:. Files in cache.fs: these are managed by RokuOS, not the app. The system automatically evicts files from cache.fs: when more memory is needed for the system or for other apps. You may need to download files again when you need them later on. In summary, use temp: for small, short-lived files you actively manage. Use cache.fs for large temporary file you don't mind RokuOS deleting when memory is needed. Choosing the right location helps keep memory usage under control and ensure smoother channel performance.
Stop and right here. Okay. All righty. And we've got the platform stability team joining us. Hi, Don. How are you doing?
Good. How are you, Jonathan?
Excellent. So we've got questions from the audience. So let's get right into it. Any plans for syntax updates to the language instead of calling these new methods?
Yeah, why not? We don't have any plan. So for this API, for the system level API has been there for a long time, probably since the Roku OS started. And for the channel one is like for API we added is recently since probably Roku OS 12.5. So so far, yeah, we don't have any plan to update any new APIs.
Okay, next question. In the past, we observed that memory would not always get freed up right away when dereferenced. This resulted in the app always creeping up on reported memory limit. Can we expect improvements to this? Happy to elaborate if needed.
Yeah, that is a good question. So I would suggest during the development time to use the Roku Resource Monitor to monitor where the memory is holding, right? So we have this great tool, and you can see where the objects there and how soon they'll be free. So those kind of thing, I would suggest using the Roku Resource Monitor to look at those. So for the memories, some part of the memory, let's say for the channel limits, some part of them are managed by RokuOS. For example, for the video buffer, audio buffer, we manage those. And for the rest of the object, like the bright square object and all these nodes, then it's managed by the apps. So if you free it, it's not immediately free. They're probably waiting for the garbage collections. But I would suggest to use the Roku Resource Monitor to monitor that during the development time. And yeah, I think those should be free. And also the kernel is our kernel in the Roku OS will do the cleanup as well when the memory getting low. So yeah.
Okay, actually, so Chris, who asked the question, he actually wants to elaborate on this. So Chris, you're going to have to be the honor of being the first audience member to actually speak on air. So I'm going to go ahead and allow you to talk. And Chris, you are on the air.
Hi. Yeah, so I just wanted to elaborate. We've actually built sample apps in the past where we can completely confirm that the app has no reference to the nodes, and we're able to edit memory the app and get it to shut down. That's the type of issue I'm referring to, where for some reason it seems like the garbage collector is not properly actually collecting memory. And we've observed this in a real app as well, just navigating between pages. And there are no reference counts left to those objects, and they're still not getting cleaned up. So I was just wondering if anything has been fixed regarding that.
Thank you, Chris.
Was there any response to Chris's question or any thoughts or? Did we lose Don? Are you there?
Yeah, I'm here. Yeah.
Did you have any response to Chris's question?
Yeah, I think that's great. Yeah,
Okay.
I think we are in the different teams. I think Chris know more about the apps levels. I mean, the more like the system teams and provide the API for those. So I think what Chris says, I think is yeah, is
Okay.
helpful.
I mean, for further, Chris, you may actually want to, that could actually be asked if you want maybe some further clarification. We have the scene graph panel tomorrow. Um, and that may be another place. Or also you can just ping us off on Slack and we can work with you. All right, next question. I am confused. It says RO app memory monitor does not work on Liberty, but I just checked it and get channel memory limit works fine.
So the way it works is because some of the platform they use older kernel, like Liberty and Austin. Those are like has been there for 10 years. So we are not able, because the feature depends on some of the kernel features. So we are not able to get the per channels memory usage. So we don't have an isolated process for the apps running in the Liberty. So when you call the API, it works. We just return the available memory for the system. So what that means on the Liberty and all the platforms, you can use as many of the memory you could use. We don't have any limitation set to that. So as long as the system has available memory, you could use all of them. But in the new platform, when you call this API, we will give you the information like the channel limit for the channel. So in summary, yes, the API works, but is not really control. I mean, the other API may not work, right? The notification, you are not going to get the 80% of notification warning when you reach to 80% the limit because the platform is running older kernel. We are not able to using the newer feature from the kernel.
Okay, awesome. Next question. We can still only use RO app memory monitor and subscribe to the vet in the main thread. Is that correct?
Yes, I think for your app, you should always use that to do that, regardless. Some of the platform may not support this, but you should use it. Yes, you can using this for the main thread. So the bottom line is you can using the API for the channel basis one, as well as the system one. And when you receive the notification, you can do the same thing, right? You are going to drop some of the cache you have and release some of the nodes and drop some of the cache, the files under the TAM. So yes, so basically you need to consider both the system levels memory as well as the channel, the memory limitation.
Awesome. All right, just any more questions, guys, before we break for lunch? Guys have a few more minutes. Any other questions, guys? The floor is yours. Here's your opportunity to interact with our finest engineers. So
Oh, we can talk about football, Jonathan.
we can talk about Mr. Tonjes of the 49ers, yes.
Go Niners.
Yeah. Here we go. Is run garbage collector ever run automatically in BrightScript?
Chris, can you answer this question, please?
Hold on. I have Vinay. So also, Vinay, I've unmuted you, so you actually can talk.
Thanks, Jonathan. I think this question, Chris would be in a better position to answer, but the reason I raised my hand earlier was to ask a follow-up question to what Chris was elaborating on. Can we follow up on that as a request, as a ticket, and we can get back to him on that?
Yeah, absolutely. We'll do that.
Is Chris online? Is he able to talk?
If Chris, by the way, the Chris that talked, you're referring to Chris Hagedorn. He's not on this panel. The Chris that responded was Chris Perkins, who will be part of the community tools. So,
Okay.
not to say that his level of expertise, almost you could ask him, like, and we definitely probably could provide a response, but he's anyway.
Got it.
Okay. Any other questions? Okay. If that's it, then oh, here we go. Any other recommendation besides dropping TEP and cache FS when reaching memory limits?
Yeah, I think that's good questions. One thing I would like to point out is like RokuOS cache some of this image if you download through a URL link. Let's say if you have some movie thumbnail, we will cache it under the cache FS. So it's better practice you don't download that into your TAM and let the RokuOS to handle that. So which means like you don't need to double cache some of these images. So yeah, that is one of the thing. The other one is like some of these object probably is off screen, like bright screen object. So I think that is the time when you receive the notification. So probably remove all those off screen object. So that will save the memories.
Okay. Any other questions? You guys have a few more minutes.
And the other thing I would like to point out, so yeah, check your developer portals and look at the matrix. One of them is called memory kosher. If you have this above the yellow line or the red line, is the time to debug your apps to use less memory and using the Roku resource monitor during the development time to look at it where there is a breakdown, right? You will see like all the object you allocated probably is not free. Try to free them if you don't need them. So yeah, so check the developer portal for the matrix, both stability and memory kosher, because sometimes when the memory getting low, you could get the stability measures like some of the API call timeout. So yeah.
Okay. Awesome. Let's see if we have any other questions. And then actually after this, we have a quick, before we do lunch, actually, we have a last panel before lunch is on our developer beta program. It's kind of a quick one. So then we'll do that and then we'll do lunch. Just double check. I think we have no more questions. So I am going to, Dawn, thank you so much for helping out. Appreciate it. And then we will, let's switch over to the beta panel. Thank you guys.